We're good? Hello. All right. Good afternoon, everyone. Afternoon. Yahawi. Wala magdili busog. All right. So good afternoon, everyone. It's so great to be here. This is not my first time to be in Davao. I'm just happy to be back to my hometown. I was born here in Davao, born right at Matina, so near JSIS village. So yeah, and then I have my grandmother used to have a house at Trading Boulevard. So the old na mga Davaoenos know the Trading Boulevard. I think you've renamed that street now already. But yeah, I grew up in Cagayan de Oro. So grew up in Cagayan de Oro and have a family there. But from time to time, I also come to Davao. So yeah, Davaoenyo, proud and loud. Anyway, so I have to change my display setting. Wait lang. Sorry about that. Let me mirror. Okay. There you go. Keep. All right, let's go. So my talk for this afternoon is going to be about managing Kubernetes using Python. Who here is doing infrastructure? DevOps. Okay, GKE, AKS, no? All right, so this might be for you, but for the developers out there, you may learn a thing or two probably. So, by the way, my name is Romar. I've been in the industry for more than 20 years. I've been doing, what happened? I don't know what happened. Anyway, so I've been doing tech for more than 20 years. I've been doing tech evangelization and open source advocacy for several years already. I co-organized PyTsada, which is our Python advocacy group in Cagayan de Oro. Freyla is basically one of our members. She then started organizing Django Girls from within PyTsada as well. I'm also a part of Mozilla Philippines Community. I'm the regional coordinator for Mozilla Philippines for Northern Mindanao. And of course, from time to time, I also volunteer for Python PH, helping out, whenever I can. I also volunteer for Fedora. In fact, I have a Fedora email as well, fedoraproject.org for hardware. And I'm also a voting member for Open Infrastructure Foundation, which used to be called OpenStack Foundation. And then other communities as well, but I don't want to mention them anymore. Right. So basically, my talk is about how you can use Python to manage your Kubernetes clusters. Who here is using Kubernetes right now? Docker. Who's using Docker? You're using Docker right now. Docker Swarm or Docker just plain Docker? Plain Docker? How do you self-heal using plain Docker? Just for development, local development, right? But when you're going to be pushing your container images to production, how do you do that? Most definitely, you're gonna be using Kubernetes to do that, all right? So, for those who do not know what Kubernetes is, let's just take a look a little bit. So, Kubernetes, basically pronounced Kubernetes, is basically a container orchestration that was developed within Google, and then they open sourced it. And more than what Docker can provide you, within Docker you can just create a container image and then run it, right? So you package your project into a container image, and the container image becomes a readily deployable unit. So you can then push that to whatever container registry you have on the cloud. You could push that to Docker Hub. You can push that to wherever. You can actually run your own container image, container registry, and then you deploy that multiple times without really rebuilding again, because you already have a deployable unit. But with Kubernetes, instead of using Docker Swarm, Kubernetes will allow you to have your application self-heal and running perpetually as long as the Kubernetes platform is working. Anyway, I'll demonstrate that later as well. So it's actually a rich platform with several capabilities, more than what you can have with Docker Swarm. But in Kubernetes, especially for those who are already managing Kubernetes, you're more familiar with these tools. kubectl, which allow us to manage traditionally your Kubernetes infrastructure. Or most of you might be deploying applications using Helm. Helm install whatever, like Helm install MySQL, Helm install Postgre, Helm install Django, or Helm install whatever application that you've built, and you have created a Helm chart for that. Or you can actually also use Customize, which is similar to Helm. Or you can also use K9s, K9s, or you can also use another tool called Lens. Okay, later I'll show you what K9s look like. But most of us then will actually take it a step further by creating infrastructure as code. You're familiar with infrastructure as code, right? IAC. Okay. Now, from our team, we usually use Terraform for that. So we just create a set of Terraform scripts, or what we call as Terraform recipes, all the specifications for the server, the sizing, the CPU, the memory, everything, and then we just run it. Run the Terraform, and then the Terraform will provision the entire infrastructure for us. And we can repeat it without, avoiding the human factor of, there's a typo somewhere, or there's a semicolon somewhere. So once you have codified your infrastructure deployment and your provisioning, and you can just idempotently redeploy without any problems. All right, but the question is, sir, you already have several tools that you have named. Why would you want to manage your Kubernetes infrastructure using Python? Okay, why? Why should you dive into that? Number one is you might be more familiar with Python. You're comfortable with using Python. You don't want to, dive into another set of tools. Just use Python, like you love Python more. And you can integrate your Python code or your Python scripts that will help you manage your infrastructure, can be integrated into your CI/CD and to automate things. And it's also, another thing is that Python has a really rich ecosystem and a very familiar syntax. I'm pretty sure you know what I'm talking about because you're Pythonistas here. And last is that there's an official Kubernetes Python client that you can use. And then you can immediately just use it and then manage your Kubernetes infrastructure using Python alone. Okay? So let me introduce to you the Python client for Kubernetes. So the K8s Python client is basically the official Python client maintained by the Kubernetes community or the K8s community. And what's nice is that it maps Kubernetes API calls directly into Python objects. So you don't need to, am I familiar with the Kubernetes API? You don't need to learn Kubernetes API anymore. You just learn how the Python module for Kubernetes works, and then you can manage your Kubernetes infrastructure. Because everything there is going to be Python objects already. And it supports all Kubernetes operations, from CRUD to watch, exec, logs, etc. From the life cycle, you can manage the entire life cycle of your Kubernetes workloads using only Python. Okay, so it has several modules. The more prominent modules for the Python client in Kubernetes is you have a client module, you have a config, you have a watch, and you have a stream. So you can actually continually manage your Kubernetes cluster, streaming it to your managing computer. And it doesn't matter which cluster you're going to manage. You can manage local clusters on-premise, you can manage GKE, you can manage AKS, you can manage AWS Kubernetes clusters as well. Doesn't matter. As long as you have your context available, you have your kubeconfig available, then you can manage your Kubernetes clusters using Python. So how do you do that? So here's basically it. Can you see the left side? So that's basically an existing Kubernetes cluster on my laptop right now. I'm running K3D. So if you're familiar with K3D, that's Kubernetes cluster. That's Kubernetes running on top of Docker. So I have here namespaces available. So you have default and then the generic cube namespaces here. So in order for me to do the demo, I will need to create a new namespace. Let me see if I am actually on the right context. So the context is K3D PyCon Davao, so it's correct. Now, I will need to create a new namespace. Create namespace, PyCon Davao. Why am I doing it like this? Because I want to make sure that you will see that I'm not just bullshitting here and then creating a pre-created video for you guys. See? It's already here. It's created. Now, I will now show you the code that will be executed later in my demonstration. I'm not sure if it's really clear for you guys. Let me zoom in. All right. So here, we instantiated our module for Kubernetes, the Python client. And then here, first demo, is going to be establishing a connection to the Kubernetes cluster. No, look, there's nothing alien about this. This is just Python, man. You just do API calls, that's it. So you can actually, if you're managing Kubernetes before, you will actually see some familiar things, like you can create deployments here, right? Okay, instantiate the deployment in the format. Instead of creating Helm charts or YAML files, you just create an API call using Python. That's it. See? Even instantiating for the containers that will be used. Okay, here. So you can also do scaling. You can actually scale your deployments in Kubernetes. So you can have multiple, you can actually scale it up and down. So we have what we call as horizontal pod auto scaling, or you can do vertical scaling. So you can, here's the thing that you cannot do with traditional application servers. You cannot just inadvertently scale your instance multiple times without doing some magic tumbling. But in Kubernetes, we can scale it up or down anytime. Okay? So, another things here, you can also watch for events. You can actually monitor if you want to get logs. You can do it also. Okay? You can run arbitrary execution of commands on the containers themselves that are running on top of Kubernetes. Okay? And you can even clean up. Okay? So, let's see how it will fare. Now, so we have our namespace already created. So let me go to that namespace. Now let me run my demo. You've seen the code. Let's see how it behaves. Oh, sorry about that. All right. So the first run, it shows you basic cluster information. Our API, our Python client already got it. No? This information was just fetched from the Kubernetes cluster directly using our Python code. Next, it's now going to create a deployment. Look on the other side. What will happen? Okay. I'm on the wrong namespace. Let me see. Because it's actually under the default namespace. Here it is. Okay? So our Python code actually deployed our application with 3 pods running. Now, here's also the power of Kubernetes, because Kubernetes has self-healing properties, like a superpower. If you're going to delete your servers right now, will it come back automatically or not? So I'm going to delete one of the pods, basically one of the server instances here. It's terminating, but take a look. What happened? It runs it back. So on Kubernetes, your application will become fail-proof. It will automatically self-heal if one of your instances will actually go down. Right, now, so the next demo is it's going to automatically scale from 3 pods, it will automatically scale to 5. Our Python code did that. And it scaled up automatically. Now, what's the significance in a real-world application or a real-world scenario? If you're going to be able to scale it up and down, your application will become much more responsive and will be able to handle more traffic. And what's stopping me from running 100 pods in order to handle thousands of requests per second? I can do that with Kubernetes. No? And we just did that using Python without anything special. All right. Next, you can now monitor using Python code for Kubernetes. You can monitor your pods as well, the health of your pods. You can take a look at it. You can also take a look at the logs. So these are coming from the logs on each of the pods that are running on your Kubernetes cluster. Okay? And here's an example of it running or executing arbitrary commands on the pod of the cluster. So it just fetched some information of the workloads on the cluster, and then we print out a simple text, hello PyCon Davao 2025. Okay, we just did that using Python. Nothing else, just Python. Okay? And it will now kill our workloads. So you can do whatever it is that you want to do on your Kubernetes cluster. From the initial provisioning all the way to the destroying of the instances. If you're going to decommission your cluster, you can do that using Python alone. Okay? Now, the question is, we don't need a video. We already did the demo. So for best practices, if you're going to be managing your Kubernetes clusters, number one is, of course, you need to make sure that you'll be using kubeconfig as well. And you need to make sure that your namespaces are properly set up and named. Always make sure that you wrap your API calls in try except. So if you notice sa code natin earlier, we always have try and except so that you'll be able to trap and intercept errors as well. Okay? And that's very, very foundational and basic on Python. Okay? And make sure you use context managers where possible. You use RBAC. No? If you're managing Kubernetes, don't neglect RBAC. Okay? Role-based access control. And do not hard-code credentials. And then if you're going to be doing integration tests on your local machines, you can use K3D instead of using your actual live Kubernetes on the cloud. Okay? And then you can also reuse API client instances and use watches for monitoring. Okay? Now use cases. Okay? You can use custom operators and controllers for your Kubernetes application using only Python. And then you can enrich your CI/CD pipeline integration. You can have you can create your own, technically. No? You can create your own platform engineering tools using Python. Or you want to use Air and create a Kubernetes platform management solution, you just use the Kubernetes Python client and boom, you'll have a platform engineering tool that is uniquely yours for your team. Okay? And you can also use this to do infrastructure testing because it's just Python module. So you can combine it with other testing tools which are already available in Python, right? Okay? And you can also create cost optimization scripts because remember, you can now fetch information from your Kubernetes cluster using just Python and you can create calculators. You don't need the calculators from your cloud provider. You calculate whatever it is that's being utilized by your workload from your Kubernetes cluster. Use Python. And last but not the least, you can create your own backup and disaster recovery automation using Python. And you have a lot of other third-party modules that are already available in Python that you can combine with the Python client, Kubernetes client for your Kubernetes clusters as well. All right?